Hi students, in my last video I have covered a reaction of amine with aryl sulfonyl chloride. Next we have also learned electrophilic substitution reactions of aniline, and we have also started diazonium salt. In the diazonium salt also we have learned the preparation of benzene diazonium chloride. In today's class, that is lecture number 8, we'll start with the physical properties of diazonium salt. Right, the physical properties are like this. The first physical property of diazonium salt is benzene diazonium chloride is a colorless crystalline solid. It is right. It is a colorless crystalline solid. Second point, it is readily, nothing but easily soluble in water, and it is stable in cold and reacts with when warm. I'll repeat. It is readily soluble in water. Why benzene diazonium chloride is easily soluble in water? Because benzene diazonium chloride is having ionic in nature. Because of that reason, it is easily soluble in water, and is telling that it is a stable. Benzene diazonium chloride is stable at a cold condition. If you heat slightly, then it is undergoes hydrolysis. Right. Then it decomposes easily in the dry state. These are the physical properties of benzene diazonium chloride. Then we'll enter into chemical properties of benzene diazonium chloride. Let's see total how many types of chemical properties are there. We'll discuss now. Right, chemical properties. Here, mainly we will have two types of chemical properties for this diazonium salts. Number one is you can say like this. Otherwise, A includes that is displacement of reactions involving displacement of nitrogen, or you can say that the displacement of diazonium group. Next, B, retention, nothing but reactions involving displacement of diazonium group, reactions involving retention of diazonium group, or nitrogen, of course, diazonium group. Both are same only, right? We will discuss here mainly two types of chemical properties. In that first type chemical property includes displacement of diazonium group, nothing but displacement of nitrogen. Second type includes the retention of diazonium group. Now we will discuss about the first type, that is displacement of nitrogen. Then how the nitrogen is displacing, let's discuss now. Right. Then here in the number one, displacement with like halide ions. There is a Cl minus, Br minus, and Cl minus. Displacement with Cl minus, Br minus, Cl minus. Nothing but the diazo group is replaced by these substances. Or you can write replacement of, also you can write replacement with Cl minus, Br minus, Cl minus, and this reaction is also called as is a name reaction, Sandmeyer reaction. Sandmeyer reaction. Let's see what is Sandmeyer reaction and how these groups are displacing the nitrogen. That is nothing but diazonium group. We'll see now. Right. We'll take a diazonium salt generally like this. Ar N2 plus X minus, general diazonium salt is reacting with HCl in the presence of copper oxidation number 1 ion, Cu1 ion. Cu1 ion is nothing but Cu. We can take CuCl or Cu2Cl2 oblique HCl. Here copper oxidation number is 1. If you take CuCl, HCl, this diazo group is replaced with the Cl, of course. So you get ArCl, chlorobenzene, nothing but. I'll repeat. When the benzene diazonium salt is reacting with copper 1 ion, copper 1 ion with HCl. Then diazo group is removing and chlorine is coming and substituting, you will get ArCl. We can also write Cu2Cl2 also, doesn't matter. Cu2Cl2. And the second one is Cu2Br2 oblique HBr. Cu2Br2 we can write or CuBr also we can write, both are same only. It is also copper 1 ion only with HBr. Then the diazo group is removed and Br is coming and substituting, you will get ArBr is obtained. Bromobenzene we can say. And next we will write CuCN. Cyanide ion is replacing now. CuCN oblique KCN in the presence of KCN. Alright. Then here diazo group is replaced with a cyanide group. You will get ArCN is obtained. Its name is benzonitrile. Benzonitrile is obtained. And these three reactions nothing but Sand-Mayer reactions. I'll repeat once again. Diazonium salt is reacting with HCl. In the presence of copper 1 ion, you will get ArCl. Same diazonium salt is reacting with HBr. In the presence of copper 1 ion, you will get ArBr. Nothing but bromobenzene. Same diazonium salt is reacting with KCl. In the presence of again copper 1 ion only, you will get ArCl. These reactions includes Sand-Mayer reaction. Then it's a similar one more type reaction is there, that is called as Gattermann reaction. Gattermann. Sand-Mayer, Gattermann reactions almost seems to be same only. We will discuss now what is Gattermann reaction. Same, again I am taking a general diazonium salt Ar(N2 + X minus). Okay, that diazonium salt is reacting with, now it is slightly different, reacting with HCl of course, reacting with HCl in the presence of copper metal, copper elemental state, copper metal. Here copper ion Cu1 oxidation number, but here Cu0. I'll repeat, diazonium salt reacting with HCl in the presence of copper metal. Then Cl is coming and replacing the diazo group. You will get ArCl plus byproducts of course N2. Just a minute. Sorry, here also we can write a byproduct. Nitrogen gas escaping here in all three cases. Nitrogen gas escaping from diazonium salt. Right, come here. Here also after elimination, after displacement of Cl here, nitrogen is escaping, and along with that CuX is obtained as a byproduct. Right. Next, same diazonium salt is reacting with HBr in the presence of again copper metal. Oxidation number is 0. Here oxidation number is 1. See the difference between Sand-Mayer as well as Gattermann reaction. In Sand-Mayer reaction, copper 1 ion we are using. In Gattermann reaction, copper 0 oxidation number we are using. Right. Again, same Br minus is coming and replacing diazo group. You will get ArBr plus N2 plus CuX is forming. That's it. Okay, those two reactions includes Gattermann reaction. These three reactions includes Sand-Mayer reaction. Now here we are getting chlorobenzene, here also we are getting chlorobenzene. Here we are getting bromobenzene, here also we are getting bromobenzene. But if you observe the yield of both, in Sand-Mayer reaction, in Gattermann reaction, yield if you compare, yield output if you compare, definitely in case of Sand-Mayer reaction, in Sand-Mayer reaction only, yield is more than the Gattermann reaction. That's it. In Sand-Mayer reaction, yield is more than the Gattermann reaction. It is just a comparison only. When we are comparing Sand-Mayer reaction as well as Gattermann reaction, where we will get a more amount of product, obviously in Sand-Mayer reaction we will get a more amount of products. That's it. Okay, right. Next, some more examples, some more reactions we will discuss regarding the displacement of diazo group. Right. Next one is replacement by iodide ion. How iodide is replacing the diazo group will discuss now. Very simple. Here N2 plus Cl minus one diazonium salt I have taken. When this diazonium salt is reacted with potassium iodide, then what happened? N2 is eliminating, N2 is removed, and iodine is coming and substituting. You will get iodobenzene along with that nitrogen gas escaping plus KCl is obtained as a byproduct. Iodobenzene is obtained. Now here we will discuss one important point, that is suppose just imagine if I take a normal benzene, when normal benzene is reacted with iodine, what we are expecting, then here iodine means one of the iodine is coming and substituting on the benzene, you will get iodobenzene plus here from hydrogen we are removing and here I we are removing, HI is obtained as a byproduct. Means direct iodination if you do, we will get iodobenzene. With the diazonium salt also we are getting iodobenzene. Both are same only, remember once again. With the diazonium salt also, then when reacted with potassium iodide, we will get iodobenzene. Exactly. Benzene also, when we are doing the direct iodination, here also iodobenzene is obtained. But this reaction we are not preferring to get iodobenzene. We will prefer this reaction only to get iodobenzene. Why we are not preferring this reaction is important point. Because here one of the product we are getting, that is hydrogen iodide. Let it, what is the problem? Problem is hydrogen iodide is a strong reducing agent. Let it, what is the problem? Yes, exactly. This reducing agent reduces iodobenzene to iodine. Means again backward reaction takes place if you do directly like this. Repeat, because of formation of hydrogen iodide, which is a strong reducing agent, this reducing agent reduces iodobenzene to again iodobenzene to iodine. Backward reaction takes place to prevent this one. If backward reaction occurs, what happens? Iodobenzene formation is very less. That's why iodobenzene we are not getting a direct iodination process. Iodobenzene we will get from benzene diazonium salt only. Right. It is the advantage of diazonium salt. Same point we will learn in the advantages of diazonium salt. It is also one of the point. Well, because direct iodination we are not doing to get iodobenzene, then we are getting iodobenzene from diazonium salt only. Right. Exactly. Another reaction, replacement by F minus chloride ion we are replacing. Right. Replacement by F minus. Here also one important point I have done, that is normal benzene. If direct fluorination occurs, here also fluorobenzene we are getting, of course. Fluorobenzene we are getting and HF is obtained. Right. Of course, HF is not a reducing agent, leave it. But this direct fluorination also we are not doing to get fluorobenzene. I repeat, direct fluorination also we are not doing to get fluorobenzene. This fluorobenzene is obtained again from benzene diazonium chloride only. First, we will do one thing. I will give you reaction. After that, I will tell you its reason. Why this direct fluorination is not possible? Let's we will discuss later. First, I will give you its reaction. See here reaction how it is. When Ar N2 plus and of course Cl minus reacts with an important point is HbF4. Its name is fluoroboric acid. If it is reacted to fluoroboric acid, HCl eliminates, we will get another intermediate salt is obtained. Ar(N2 plus BF4 minus is obtained. That is aryl, there is a diazonium fluoroborate or benzene diazonium fluoroborate. one of the intermediate compound is obtained. This intermediate compound, when we are heating, you will get ARF. One of the F is coming and replacing the diazo group, plus nitrogen is escaping. Along with that, remaining is BF3 is obtained as a byproduct. Right. Now, here also we are getting a fluorobenzene. Here also we are getting fluorobenzene. But we will prefer this reaction only. We will not prefer this reaction. Why? Because always remember, direct fluorination explosion takes place. That you have to remember. Generally, whatever the reactions may be organic reaction, direct fluorination explosion takes place. That's why we never use this reaction to get fluorobenzene. We will use that reaction only to get fluorobenzene. It is also one of the advantage of diazonium salt. When diazonium chloride reacts with fluoroboric acid, you will get a benzene diazonium fluoroborate, and that fluoroborate is heated, you will get a fluorobenzene. Along with that, byproducts are obtained. Right. Next, some more displacement reactions we discuss now. Now, the replacement with hydrogen. A replacement with hydrogen. Then how hydrogen we are replacing in place of diazo group? Let's discuss now. See here, very simple. That is Ar N2 plus Cl minus diazonium salt. Here are two types of reactions we are having. First I will give you here number one. Right. Here this diazonium salt, when it is reacts with H3PO2 in the presence of H2O. H3PO2 in the presence of H2O, that is our phosphinic acid. Phosphinic acid. Then what happens? I will give you just a trick type only. Please remember, that is here nitrogen elements in place of nitrogen from what? It's just a trick only. We will have two hydrogens. One hydrogen is coming and replacing. You will get ARH, nothing but benzene, right? Next, one more hydrogen and Cl is HCl, plus remaining is here oxygen is coming and adding here. You will get H3PO3 is obtained. Means here overall what happened? Diazonium salt when reacts with a phosphinic acid, its another name is hypophosphorus acid. When diazonium salt reacts with hypophosphorus acid, then you will get a benzene, and after that some byproducts are obtained. Now, whatever the acid we are using, this acid is acting as a mild reducing agent. What is the role of reducing agent? Reducing agent is reducing others and itself undergoes oxidation, because here we have two oxidants. Here we are having three oxidants. Addition of oxygen is taking place. This reaction is called as oxidation. That means reducing agents itself undergoes oxidation. Okay, that's why it is one of the reducing property. H3PO2 is a mild reducing agent which reducing diazonium salt to arene. Arene is nothing but benzene. One more reaction is there. Same Ar N2 plus Cl minus. Right. We are using here one more reagent, that is CH3 CH2OH. Ethanol, ethyl alcohol. It is also mild reducing agent. Here also you just remember the trick. The trick is then here out of two hydrogens, one hydrogen will bring and will substitute here. You will get ARH, that is arene, and here one more hydrogen and Cl, HCl. Of course, nitrogen is escaping, nitrogen, and in previous case also nitrogen is escaping, of course. Nitrogen is escaping in the previous case also. And next one is and we will get a CH3, CHO is obtaining. CH3CHO. Here also we will see what happens. Ethanol, ethyl alcohol is acting as mild reducing agent. It is reducing diazonium salt to arene and itself undergoes oxidation. Ethyl alcohol converted to acetaldehyde. Alcohol converted to oxidation process only. Okay, alcohol converted to aldehyde is oxidation process only. Right, these are the replacement with hydrogen. Means diazo group is going in place of diazo group, hydrogen is coming and substituting. Right, some more reactions we will discuss regarding the displacement process. That is AR will write replacement with hydroxyl group OH, hydroxyl group. How hydroxyl group is replacing? Just will discuss now. Very simple. AR N2 plus Cl minus benzene diazonium chloride. Then already know you this benzene diazonium chloride is stable at 273 to 278 kelvins only. Suppose if temperature is slightly raised, that is from 278 to nearly 283 kelvins temperature if you raise, then immediately what happens? Undergoes hydrolysis takes place. Because of hydrolysis, what happened? Diazo group is going. Diazo group is replaced by OH group. You will get phenol, AROH, and of course nitrogen is escaping. Plus here one H is there, Cl is there. HCl is obtained as a product. I'll repeat. Benzene diazonium chloride is stable at ice cold condition 273 to 278 kelvins. But if temperature slightly raised from 278 to nearly 283 kelvins, immediately undergoes hydrolysis. Because of hydrolysis, we will get a phenol. Phenol is final compound in this reaction. Means there is N2 removed, OH group is coming and substituting. Right. Next one is the replacement with the NO2 group. How NO2 group is replacing? We'll see now. Replacement with nitro group. How nitro is replacing? We'll see now. Okay, see here you can use AR, N2 and Cl minus. Instead of AR, we can also write ring also, doesn't matter. Now I'll use ring here. Benzene ring, N2 plus Cl minus. Now here this reaction is somewhat similar to replacement by F minus ion only. Here also first we are reacting with the HBF4, fluoroboric acid. If it is reacting with the fluoroboric acid, what happens? HCl eliminates. BF4 is coming and substituting. You will get a benzene ring with N2BF4, N2 plus BF4 minus. Benzene diazonium fluoroborate. When this benzene diazonium fluoroborate is heated, you will get fluorobenzene. Now we are not heating, we are reacting with the sodium nitrite in the presence of copper metal. Sodium nitrite. If it is heated with the sodium nitrite, then immediately diazo group is removed and the NO2 group is substituting. Nitrobenzene is obtained. Along with that nitrogen gas escapes. And remaining point is NaBF4. NaBF4 is obtained as byproduct. Right. This is a replacement of replacement with nitro group. Means a diazo group is removed, in place of a diazo group, NO2 group has substituted. These are the displacement of diazo group reactions. Means in all these cases, N2 we have removed, in place of N2, other group has substituted. Displacement reactions. Next we will enter into second category reaction, that is a retention of diazo group. We will see then retention of diazo group. B category reactions. Retention of diazo group. Right. Then this retention of diazo group is called as coupling reactions. Coupling reactions. We are having a total 2 types of coupling reactions. We will discuss both reactions like this. Here, one important point please try to understand, that is benzene diazonium chloride. Already in the last video only I have explained, N2 plus, its clear structure is a bond, N triple bond N. First nitrogen is having a plus charge, second nitrogen is having a lone pair. Exactly, first nitrogen is having a plus charge, second nitrogen is having a lone pair. It is a benzene diazonium ion. Right, when this benzene diazonium chloride, here we can write Cl minus. Cl minus is not having any role here, of course. Right, then when this benzene diazonium chloride is reacting with phenol, otherwise you will write clearly like this. First, for understanding purpose I am giving structure like this. Both are same only, no doubt. N triple bond N. Here we are having a plus charge, lone pair, Cl minus plus phenol. Right, this is phenol. When the benzene diazonium chloride is reacting with phenol, let's see what happens. Already know you, phenol is acidic nature. Phenol is acidic nature. Being acidic nature, reaction takes place in the presence of base. That's why here we can also write pH range is nearly 9 to 10 pH range will be there because reaction is taking place in the presence of base. Here one important point we have to remember, that is phenol. Phenol nature will just pick up. Phenol means here OH group is just like NH2 group of aniline type only. OH group is a ortho para director. Because of OH group only, and ortho and para electron density increases. It is just because of resonance, of course. It is ortho para director as well as ring activator. It is quite similar to NH2 group of aniline. Okay. Now what happens? Suppose if any electrophile should attach. Generally, where electrophile will come and attack? Where electron rich center is there, then only obviously electrophiles will come and attack. So electrophiles should come and attack at ortho as well as para position only. In case of phenol, same thing happens. Phenol, it is phenol. Then it is main group. To the main group, this is both are ortho groups, and this one meta group, and it is of course para group. This electrophilic substitution should occur either ortho or para. That's it. Then where is electrophile? It's a question mark. Here electrophile, where electrophile is there, how electrophile is coming and back is the question mark. Right, very simple. Electrophile is producing like this. Try to understand electrophile, how it is generating. Very simple. Here, generally what we will think, here this nitrogen is having pressure. That's why this nitrogen is electrophile going and attacking. That is absolutely wrong. That nitrogen is not electrophile in coupling reactions. Instead of this nitrogen, that is nothing but a terminal nitrogen is an electrophile. Then why terminal nitrogen is an electrophile? Terminal, but last. Why it is electrophile? Let's discuss now. Very simple. Being a plus charge, it is taking this pi electrons towards itself. When it is taking a pi electrons towards itself, how it's structured? Change. Let's see here. After shifting, then this bond pair is turned as a lone pair. That's why this nitrogen is getting one lone pair. We'll have only 2 bonds. Nitrogen, of course, this nitrogen also lone pair. But here surrounding of this second nitrogen, we have 1, 2, 3, 4 electrons only. That's why this nitrogen is getting less charge. Terminal nitrogen is acting as electrophile. That is very important. Then how electrophile is producing? Very simple. These pi electrons are shifted. When pi electrons are shifted, this bond pair is turned as a lone pair. Triple bond converted as a double bond. Because of double bond, this terminal nitrogen is getting positive charge. Then what happened to this nitrogen? This nitrogen is in neutral, neither plus nor minus, because 1, 2, 3, 4, 5. 5 out of 5 electrons are present. No plus charge, no minus charge on first nitrogen. Only terminal nitrogen is acting as, having plus charge, which is acting as an electrophile. This electrophile will go and attack at para position. Why it is not attacking at alpha position? Because it is absolutely bulky group. This bulky group is not possible to attack at ortho because already OH group is there. Between OH group and this group, between OH and this group, repulsions existed. That's why this electrophile instead of ortho, it prefers to attack at para position only. Which nitrogen? Terminal nitrogen is acting as electrophile. This terminal nitrogen is preferring to attack at position, not at ortho position. Therefore, will get a compound, a conjugated system is obtained. Let's see what happens. It is benzene ring. Here instead of well right here after shifting will get plus charge. This will go and attack at para position, and here triple bond converted as double bond. Therefore, nitrogen lone pair, double bond, this nitrogen also lone pair. Then this electrophile after going and attacking here, its plus charge will be nullified. After going and attacking, because there minus charge is there, this minus, this plus, this minus, this plus will be nullified. No more charges. Directly we write benzene ring OH, right. If you observe the structure, okay, then what are the byproducts? Byproducts are Cl minus and H2O. Cl minus and H2O are the byproducts. What is the advantage of this product? What is the greatness of this product? Is very simple. It's a system if you observe double bond, single bond, double bond, single bond, double bond, single bond, double, single like that. Will have conjugated double bond. Conjugated double bond system is existing here. Because of that conjugation double bond, the product is stable. And what is its name? Its name is para hydroxy. Because to this group it is para position. To this group it is para position. Para hydroxy, azo. This N double bond is nothing but azo. Benzene. Don't tell dibenzene, just benzene. Para hydroxy azobenzene is obtained. Right here. Para hydroxy azobenzene. And one more important part is whatever the azo compounds we are getting, these azo compounds are dyestuffs, colored materials. And its color is orange color will be orange dye, you can say orange dye it is. Which one? Para hydroxy azobenzene is orange dye substance. Once again, it is benzene diazoyl chloride. It is reacting with phenol. Phenol being acidic nature, reaction takes place in the presence of base. That's why pH value we are maintaining from 9 to 10 almost. And here one substance obtained. Its name is para hydroxy azobenzene, and it is orange dye substance. And here what is electrophile? Electrophile is a terminal nitrogen, not inside nitrogen. That terminal nitrogen being electrophile is going and attacking at a para position of phenol. Therefore, you get that. Exactly. Instead of phenol, I make a second reaction. It is number one, of course. Second reaction, another coupling reaction. It is called as coupling. Why it is called coupling? Because both the rings are coupled. That's why it is called a coupling reaction. Another coupling reaction I will discuss, which is almost similar to this reaction. That is a reaction with aniline being of basic nature, reaction takes place in the presence of acid, of course. Acid means a pH value below 7 and take a pH value from a 4 to 5 range. Being basic. Being a basic reaction takes place in the presence of acid. Same reaction takes place again by electrons are shifted. Then this nitrogen plus charge is shifted from here to here. This terminal nitrogen is getting plus charge. Exactly. That plus charge will come and attack at para position of this NH2 group. NH2 group also are para director. That's why at para position electron rich center will be generated. At that rich center, terminal nitrogen will go and attack. Therefore, the final compounds are, say, instead of OH will write NH2. Byproducts also same. Then what is its name? Instead of hydroxy will write para-amino. Para-amino azobenzene. Para-amino azobenzene. And its color is yellow distuff. Yellow distuff substance. That's it. Both are coupling reactions. One is with phenol, one is with aniline. Well, guys, here also we are having extended conjugated system. Means a double, single, a double, single, a double, single, a double, single, extended conjugated system is developing. Because of that reason, the products are stable. And its name is para-amino. Because to this group, it is para position only. Para-amino, azobenzene is a thing. Right. These are the retention of diazole. Retention. What is the meaning of retention? Retention is keeping as it is. We are not removing. We are keeping as it is. What we are keeping? It's a diazole group. We are keeping as it is. We are not removing the diazole group. In previous reactions, N2 has removed. But here, N2 has not removed. See the product, N2 is there only. N2 has not removed. It is called retention of N2 group or retention of diazole group. Okay, one is replacement of diazole group and retention of diazole group. We will have two types of chemical properties. Both the types of chemical properties we have completed. Right. Now finally we will discuss about advantages of diazonium salt. What are the advantages of diazonium salt? Let's discuss now. Advantages of diazonium salt. Very simple. Already 2-3 advantages are known to you. One is, just now we have discussed, when benzene is reacted with iodine, we are getting iodobenzene, no doubt. And along with that, HI is obtained. But this reaction to prepare iodobenzene, we are not preferring. Because here backward reaction takes place. Backward reaction is taking place. Direct substitution of iodine we are not preferring. Instead of that, we are using diazonium salt Ar(N2) plus Cl minus. This diazonium salt is reacted with potassium iodide. Then iodine will come and displace nitrogen and you will get Ari and of course byproducts are obtained. Means with the help of diazonium salt only we are getting iodobenzene, not direct iodination. Therefore, it is also one of the advantages of diazonium salt. Diazonium salt is an intermediate compound. Because of diazonium salt only, we are getting iodobenzene. It is one advantage. Another advantage also known to you. That is, when benzene reacts with fluorine, we are expecting like this chlorobenzene and of course HF. But this direct fluorination also we are not preferring. Because the direct fluorination explosion is taking place. To prevent that one, instead of direct fluorination, again we will use diazonium salt. With the help of diazonium salt, we will get fluorobenzene. How? Just now we have discussed that. When this compound is reacting with HBr4, fluoroboric acid, we will get one compound, intermediate compound. That compound is heated. Finally, we get a fluorobenzene. Both are advantages. Direct iodination we are not doing. Instead of that, we will use diazonium salt. Direct fluorination also we are not using. Instead of that, we are using a diazonium salt to get both the components. Right. Next, these are the advantages. Next advantage is, with the help of diazonium salt, just now in Sandman reaction, in all Gatterman reaction we have learned, we can prepare from diazonium salt. We can prepare like chlorobenzene we can prepare, as well as bromobenzene we can prepare, as well as benzonitrile we can prepare, as well as iodobenzene we can prepare, as well as fluorobenzene we can prepare, as well as arene we can prepare. We'll continue. As well as nitrobenzene also we can prepare, as well as phenol also we can prepare. All these reactions are just now in its chemical properties we have learned. These are also advantage only. With the help of benzene diazonium chloride, all these compounds we have prepared. This compound is acting as an intermediate to get variety of aromatic compounds. That's it. This is our amines topic. But here one important point is in lecture number 3 of in my videos, lecture number 3, one small mistake is there from our side. That is lecture number 3. It includes preparations of amines. Preparation of amines like Miss Hoffman's ammonolysis process, reduction of amines, reduction of nitriles, and Gabriel thalamide synthesis. And these topics, because of some technical issue, these topics are erased from my lecture number 3 video. That's why very sorry for that inconvenient. That's why in my last video, once again I'll explain all the concepts. That's why please don't worry about that. That is my request from my side. Okay. Thank you for watching. Bye.